All right, all right, all right. Graphing rational functions. Now this time we're going to graph the rational functions, or a couple of them. It has a kind of a unique situation where you see up there at the top it says n equals m plus 1. What that means is that the degree of the leading term of the numerator exceeds the degree of the leading term of the denominator by 1. And when that occurs, when we have that situation, we do not have a horizontal asymptote, but instead we have what is called an oblique asymptote or a slant asymptote. In other words, we got an asymptote that takes on a linear function. So here we've got this rational function, and we're asked to find any asymptotes in the intercepts and then graph the function and state its domain. And we'll graph it a little bit later because we're going to focus on the asymptotes and the intercepts. Now we know that a vertical asymptote is going to be created by any number is going to create to try to divide by 0. And so we can take that denominator, set it equal to 0, solve for x, and we have a horizontal asymptote when x is equal to -4. And I'm going to just label this as HA, horizontal asymptote. I'm going to save the slant asymptote for a little bit later. Got to make sure I got enough room. All right, let's find the intercepts then. So if we want to find the x-intercept, we set y, or h of x, equal to 0, and then we're going to solve. So we got x squared plus 3x minus 3 over x plus 4. Well, if I multiply both sides of this equation by x plus 4, 0 times x plus 4 is just going to equal x squared plus 3x minus 3, correct? So that would leave us then with 0 equals x squared plus 3x minus 3. Now, I'm looking at that quadratic equation, and I'm thinking about how can I factor that to find any x-intercepts. +3, -3. And you know what I'm going to have to do? I'm going to have to use my old friend, the quadratic formula. -b plus or minus the square root of b squared minus 4 times a times c over 2 times a. So let's set that up. So let's see, b in this case is +3, but we start off with a -b, so we got -3 plus or minus the square root of 3 squared minus 4, a is 1 times 1, and c is -3. Square root of that over 2 times 1. All right, well, let's solve what's underneath the radical. So 3 squared is going to be 9, and then -4 times 1 is -4, but then times 3 is what? +12, right? +12. So I got -3 plus or minus the square root of 12. No, 12 plus 9, 21. Square root of 21 over 2. Let's see, square root of 21. 3 times 7. So I'm not going to be able to pull out any perfect square on that. So let's see. Let's find out what the square root of 21 is. Let's see. Square root of 21. It's 4. We're going to round this to the nearest hundredth. 4.58. So then we got -3 plus or minus 4.58 over 2. All right, well, let's go with the negative 3 plus 4.58. Negative 3 plus 4.58. And then we're going to divide that by 2. And we get 0.79. So we've got one intercept. Does it tell us what they want to round it to? No. 0.79 would be one x-intercept. Let's see. And then we got negative 3 minus 4.58 divided by 2. And then we got approximately negative 3.80 or 3.79. All right, that should take on our x-intercepts. What about our y-intercept? Well, we would set x equal to 0 in our original equation. Solve for y. Well, if I put in 0 for all 3 of these x's, let's think about that. 0 squared is going to be 0. 3 times 0 is going to be 0, so I'm left with negative 3 in the numerator. And 0 plus 4 is going to be just 4 in the denominator. So I have a y-intercept where at, let's say, negative 3/4. And now I come to a little bit of the hard part, and that is finding the slant asymptote. And what I've got to do, I'm going to have to use long division. I know y'all like, well, I guess I probably could use synthetic division, but probably just as easy to use long. And I'm going to divide x squared plus 3x minus 3 by x plus 4, and we're going to ignore the remainder. Doesn't matter, okay? We're just trying to get the equation for the oblique or slant asymptote. So let's go x plus 4. We're going to divide that into, I need to move that down. I'm not going to have enough room. And we're going to divide that into x squared plus 3x minus 3. I'm still going to be short of room, but okay. How many times will x go into x squared? Well, that'll go in there x times. X times x is x squared. X times 4 is 4x. Slap some parentheses around this because we're going to subtract this. And x minus x squared is 0, and 3x minus 4x, is going to give me negative x minus 3. And how many times will x go into negative x? Well, it'll go in there negative 1 times. And negative 1 times x is x. And negative 1 times 4, is negative x. And negative 1 times 4 is negative 4. But remember, I said we're going to ignore the remainder. Even though we're going to have a remainder of 1, we're going to ignore that. And so we've got an oblique asymptote, and I'm just going to say A. I don't want to spell out asymptote, where y equals x minus 1. And we'll see that a little bit later once we graph that. So let's see. We've done the intercepts. We've done the asymptotes. We're still going to need to graph and state the domain. Let's go look at another one before we go, and then we'll use the graphing calculator for both of these. All right, so this time we've got x squared, x squared minus 4x plus 1 over 2x minus 3. So let's think first about this vertical asymptote, which is going to be created by anything that would cause the denominator to equal 0. So we're going to set 2x minus 3 equals 0. We're going to add 3 to both sides, divide by 2, and so we're going to have a vertical asymptote where x equals 3/2. Vertical asymptote. We're not going to have a horizontal asymptote because the degree of our numerator exceeds the degree of the leading term of our denominator by 1. 2 minus 1 is 1. So we're going to have an oblique asymptote. Let's see. How about the y-intercept? That's easy enough to do. I set all the x's equal to 0 and solve for y. Well, let's see. If I set this at 0, this at 0, this at 0, 0 squared is 0, negative 4 times 0 is 0, and I got 1 in the numerator. The denominator set x equal to 0, 2 times 0 is 0, and then we got negative 3. So we got a y-intercept at negative 1/3. Okay, now I really only have to focus on to find the x-intercepts, I really only have to focus on the numerator, because if I set this whole equation equal to 0 and then multiply both sides by 2x minus 3 to clear out the denominator, well, 0 times 2x minus 3 is just going to be 0. And so again, I'm looking at this wonderful equation, x squared minus 4x plus 1, the numerator, focus on the numerator. And once again, I think I'm going to have to use my old friend quadratic equation. All right, so A is 1, B is negative 4, and C is 1. Well, let's start. So I got negative B, well, that's negative 4, so that's going to just be 4, plus or minus the square root of negative 4 squared, which is going to be 16, then negative 4 times 1 times 1, all over 2 times A, which is just going to be 2. All right, so let's focus what's under the radical. So negative 4 squared is 16. And then I got negative 4 times 1 is negative 4 times 1 again, which is negative 4. So I've got 4 plus or minus square root of 12 over 2. Now, if I think about the square root of 12, that's the same as the square root of 4 times the square root of 3. I'll just write that. 4 plus or minus square root of 4 times the square root of 3 over 2. Let's save some space here for our oblique asymptote. Well, the square root of 4 is 2. So then I've got 4 plus or minus 2 square root of 3 over 2. But then I can cancel out here. So I got 2 plus or minus the square root of 3. Okay, so let's try that on. Let's say we got 2 plus the square root of 3. What does that equal? 3.73, okay. So we've got a x-intercept at 3.73, and let's do 2 minus the square root of 3. 2 minus square root of 3. And that is 2.67. We're going to round that to the nearest hundredth, or 0.27. So we've got x-intercepts at approximately 3.73 and 0.27. Oh my goodness. Now we've got to do our long division. Now let's try it. 2x minus 3. We're going to divide that into x squared negative 4x plus 1. And remember, we don't concern ourselves with the remainder to find this equation for the oblique asymptote. So how many times will 2x go into 1x squared? Well, that's going to be 1/2 x. In other words, it's going to be x over 2. All right, well, what's 1/2 x times 2x? Well, 2 times 1/2 is 1. And then x times x is x squared. All right. And then 1/2 times negative 3x, well, that's going to be negative 3/2 x. Slap some parentheses on here and subtract. X squared minus x squared is 0. And then we got negative 4x plus 3/2 x. So let's see, 4x is going to be, if I put that in terms of halves over 2, that's 8 over 2. 8 over 2. Well, that's going to be, and it's a plus, right? Negative 8 over 2 plus 3 over 2 is going to be 5 over, it's going to be negative 5 over 2x plus 1. Now I got to think. Let's see. How many times will 2x go into negative 5x? Now remember, if I'm dividing by 2, that's the same thing as multiplying by 1/2, right? So negative 5/2 times 1/2 is going to give me negative 5/4. And of course, x will go into x one time. Now let's see, negative 5/4 times 2. Do a little cross multiplication. That's going to be negative 5/2 x. And it doesn't really matter about the rest of it, but just for fun, negative 5/4 plus times negative 3 is going to be positive 15/4. But remember, I don't care about the denominator. So I've got then an oblique or a slant asymptote at 1/2, where y equals 1/2 x minus 5 over 4. All right, well, let's go to the calculator and graph these two things, and then we'll finish up by stating the domain, which we really should know right now. I mean, in this case, the domain cannot equal 3/2. It can equal any other number other than 3/2. So we could say, well, let's go ahead and write it, that the domain is equal to x such that x does not equal 3/2, and that x is an element of all real numbers. It just can't equal 3/2. What was the other one? Negative 4. X cannot equal negative 4. All right, let's go graph. We'll go from there. All right, well, here we are on the calculator. We're going to graph these two functions. Let's see. Our first function, as I recall, or I'm actually not recall, I'm going to look. Now, here's what I need to put these in parentheses, the numerator and the denominator, for my calculator to read this correctly. So I got x squared. In other words, I need to put both the denominator and the numerator in their own parentheses, plus 3x minus 3. Close my parentheses. Hit my division symbol. Get me another parentheses. X plus 4. I hope my window setting's on default. Let me go check. Yeah, let's see what our graph looks like. Okay. Now remember, we said we would have a vertical asymptote about negative 4. Well, there's negative 4. We can see there we do have an asymptote. We do not have an horizontal asymptote, but look at the shape of this asymptote that we have right here, which we determined through its equation that it was equal to x minus 1, and you can see it probably hit right through there. We had exit had a y-intercept at, what did we say, -3/4. Okay, that looks about right, whatever that is. And then we had x-intercepts at positive 0.8, roughly, approximately, and -3.8. So everything looks pretty cool right there. Let's just take a peek at the table. I want to see what's happening at -4. There's my vertical asymptote, okay? And then you can see that I've got well, I'll go from a -3 there. There will be my x-intercept would lie between -3 and -4, which we defined at approximately -3.8. And we'd have another x-intercept at about 0.8. A 0.8, and we see we got a sign change between 0 and 1. Quickly, let's graph the second one. Again, I got to put the numerator and the denominator in its own parentheses for the calculator to read this correctly. And we had x squared minus 4x plus 1 divided by, close the parentheses, hit the division symbol, start another parentheses, 2x minus 3. Close off that parentheses, and let's go look at see what the graph of this looks like. All right, so again, I've got a horizontal asymptote. We said was going to be about 3/2, and if I look carefully at that graph, that looks about correct. Seems to be going on either side. I mean, I said horizontal asymptote. I mean vertical asymptote at 3/2. I don't have a horizontal, but I got a slant asymptote running along through here, which we defined as 1/2 x, y equals 1/2 x minus 5/4. We said that we would have a y-intercept at about -1/3. That looks about right. And I'd have two horizontal asymptotes, intercepts, two horizontal intercepts at about 0.27 and about 3.73. Everything checks out. Shazam!